Hey everyone. So today we're talking about something you probably use every day without thinking about it, making computers read text for photos. Our group basically spent way too much time testing two OCR engines to see which one actually works when images get messy. Let's dive in. Okay, so why does this matter? Why should you care about OCR accuracy? Well, self-driving cars need to read stop signs in real time. Amazon warehouses also use this to scan thousands of packages per hour. And accessibility apps to read signs allow for visually impaired users. This is generally life-changing technology when it works. Here's the thing. Not all text is created equal. On the left, we have document text. This is easy mode. Perfect lighting, flat surface, clean white background, consistent font. This is like a scanned PDF or a photo of your homework. Most OCR engines were literally built for this. But scene text, that's hard mode. You got terrible lighting or too much sun washing everything out. The text is curved, tilted, sometimes upside down. The background is chaos, bricks, glass, trees, a whole bunch of random stuff. Fonts are all over the place. Different colors, different sizes. It is probably photographed by someone running to catch a bus. All right, let me introduce the fighters. In this corner, we have Tesseract OCR. This is the old school champion. Been around for over 20 years. Started at HP Labs, got picked up by Google. Now it's an open source. Tesseract uses traditional computer vision techniques. Think edge detection, pattern matching, adaptive thresholding. It's fantastic at reading documents. But it was built in an era before deep learning, before neural networks, before we had computational power to train on millions of real world images. In the other corner, we have EasyOCR. This is the young challenger, only about 3 years old. It's built on deep learning, specifically using neural networks trained on tons of real world scene text data. Its special move is the craft detection algorithm that stands for character region awareness for text detection. It's designed specifically for the chaos of scene text. The trade off, it needs more computational power, but we'll see if that pays off. So, how do we actually test which OCR engine is better? I set up 3 levels. Think of them like a video game difficulty settings. Level 1, no processing. Just takes the raw image straight from the dataset and feed it into the OCR engines. We're testing their built-in processes capabilities. Level 2, basic processing. Here I help them out a little bit, resize the images to 1.5 their original size and convert to grayscale. Think of this as training wheels, just some simple enhancements. And level 3, advanced processing. This is where I throw everything at it. I resize it to 2 times, boost the contrast, reduce the noise, and sharpen filters. The full spa treatment. This is the helicopter parent approach to image processing. For each level, I test both engines on the same 10 randomly selected images from ICDAR 2013.
Now let's take a look at one image from the ICDR database. Here we have an original image of a street sign. Here it is compared to basic preprocessing. Now here's the complete image of basic preprocessing. And now here it is compared to advanced preprocessing. Round 1, no preprocessing. Here's the raw image. Good luck, figure it out. The results, Tesseract gets 37.93% accuracy. EasyOCR had a 74.71% accuracy. Let me put that in perspective. EasyOCR is nearly twice as accurate right now out of the gate. Tesseract is already looking rough and we just started. But here's where it gets interesting. Tesseract is detecting an average of 7 regions per image, while EasyOCR is detecting 2.7. Now you might think, wait, more detections is good, right? Wrong. Most of Tesseract's extra detections are garbage. EasyOCR, on the other hand, is being selective. It's detecting fewer things, but most of them are actually correct. So winner round 1, EasyOCR by an absolute knockout. Round 2, basic preprocessing. I resized the images to 1.5 and converted them to grayscale, just some simple enhancements. The results, EasyOCR had a 77.14% accuracy. Nice, it got a little better, up to 2.4%. Tesseract had a 10.83% accuracy. Wait, let me say that again. 10.83%? Tesseract went from 37.93% down to 10.83%. It got worse, like dramatically worse. What happened here? Well, our basic preprocessing, the grayscale conversion, and resize actually made things harder for Tesseract. Meanwhile, EasyOCR was over here like, yeah, it's fine, I can work with this. So the winner for round 2 was EasyOCR. Okay, round 3. This is where I went full send. I gave these images the complete spa treatment. Resize, contrast, noise reduction, sharpening, filters, and everything. If there was a pre-processing technique, I threw it at these images. The results? EasyOCR had a 79.67% accuracy. Nice, it's the best performance yet. So steady improvements across all 3 rounds. Tesseract had a 24.24% accuracy. Okay, so it's better than round 2, but still worse than doing literally nothing in round 1. But wait, there's more. Check out the detection numbers. Tesseract is now detecting an average of 60.67 regions per image. 60.6 on one single image. Image 212, Tesseract detecting 436 regions. There were about 4 actual words in that image. 4, not 436. What is Tesseract reading? The bricks, the shadows, the windows reflections? The meaning of life? Every mortal line between bricks apparently looks like text. It's having a complete breakdown. Meanwhile, EasyOCR is calmly detecting an average of 3.1 regions per image. You know, the actual text. Here's what happened. My aggressive preprocessing enhanced everything. The text got sharper, but so did the backgrounds. And Tesseract's simple black and white binarization logic couldn't handle it. It started seeing text in every enhancement. EasyOCR's neural networks, though, they're trained on millions of images. They learn what real text looks like versus backgrounds, even when everything is enhanced. So the winner of round 3 is again EasyOCR.
Tournament results. Our OCR tournament results are clear. EasyOCR is the undisputed winner. The performance gap is staggering. EasyOCR's worst performance was 74% accurate, which is 2 times better than Tesseract's best at 37% error. EasyOCR delivered the superior performance across the board. The critical insight is a plot twist. Tesseract's best error rate of 10.83% was achieved with no preprocessing. When we tried to help Tesseract at levels 1 and 3, its performance actually degraded. This confirms sometimes that best help is no help at all. Moving forward, we recommend using EasyOCR. In our next slide, the technical T, Tesseract's approach is rigid and rule-based. It requires strictly black and white text. It works great for clean documents, but it fails miserably in the real world because it can't handle noise, shadows, or reflections. EasyOCR's secret sauce is deep learning. It uses neural networks trained on millions of images to actually learn what text looks like, regardless of the lighting or background. The analogy is simple. Tesseract is following a recipe exactly. EasyOCR is actually understanding how to cook. This fundamental difference explains EasyOCR's superiority for real-world input. In our next slide, real examples, Tesseract lost its mind. These examples visually confirm the chaos. Looking at example 1, the key box, EasyOCR was 100% accurate. Tesseract completely lost control, detecting at a staggering 436 false regions, seeing text and bricks and reflections. In example 2, the exit sign, EasyOCR was 100% accurate again. Tesseract failed again, detecting 38 regions with 0% accuracy. Tesseract's rigid pattern matching descends into chaos when faced with real-world complexity. In the next slide, the important bits. Here we will explain what we learned with this lesson. We have 4 actionable lessons from this project. 1. Context is everything. Use Tesseract only for clean PDF scans. Use EasyOCR for literally anything from a camera or scene text. 2. Newer is better here. 3. More processing equals better results. And 4. Know your tool strengths. Tesseract is the wrong tool for scene text. Our goal is now to match the right tool, EasyOCR, to the task. Thank you for looking at our slides. And in summary, we tested 10 images across 3 scenarios and found 1 clear winner, EasyOCR. The key failure point was Tesseract's record of 436 false detections in 1 image. As our picture shows, we are rejecting Tesseracts for scene text and embracing EasyOCR for reliable results.